Hey, Bio One students, it's Mr. Yant starting in on the next chapter. So this is the second half of chapter 2. So we did 2.1.2.2. Hopefully you've taken your test on that. And now we're going to go on to 2.3 and 2.4. Please stay up with the notes, just like you were just like you're sitting in class, because if you get behind on these, you're going to be very difficult to do well on my tests. So it's just like sitting in my classroom. So 2.3, yeah, we're still talking about chemistry, but we're kind of moving into taking the general concepts we learned in 2.1.2.2 and let's apply them. So we're going to talk about carbon compounds to start with. So let me kind of start with a little history lesson. So organic chemistry in the early 1800s, many chemists called compounds created by organisms organic. So we thought there were some compounds out there made up of two or more elements that only living things could make and non-living things could not. And then after we progress and we understand the principles of governing chemistry a little more, we figured out that living and non-living things are the same. That they both can produce the same kind of compounds in nature, but the term organic just kind of stuck. So it's not probably the best name, but that's the name we still use today. So what we progressed it into a new definition, and what we're going to talk about is organic chemistry is a study of compounds that have the element carbon. Carbon's the backbone of all living things, regardless we're talking about a fungus, a tree, a person, it doesn't matter. Inorganic is all the other compounds on the periodic table, all the 100 plus. So what you will take as a chemistry class, either chemistry with Mr. Anders, Miss Terry, or the gosh, I can't think of the word, physics and integrated physics and chemistry. So, whatever, regardless of what chemistry you take, you'll study more of the inorganic side of things. Now, what we want to deal with, so if you're a biology major, and this is something I had to deal with in college as a biology major, was you have to take an organic chemistry class. Very difficult class, but after you take it, you're like, oh, I get, why I need to know this, because carbon's kind of the center of everything. And it's kind of where it sits on the periodic table. So if you guys remember, we talked about how important it is to understand how many electrons are in those valence outer shells. And carbon sits there at number 6. So it's got 2 in the first orbit. And then, so if you look at a picture, let's look at a picture here. And then still has 4 more carbons. Okay. We know that those, that outer, here we go. So here we put 2 where we're supposed to, because that's the maximum, and 6 electrons, 6 protons. But then we got these 4 in this valence, which means it's very versatile. There's 4 other things that can attach here. Okay. So what can I share electrons with to get those 4 electrons? Well, there's lots of possibilities. That's what's kind of nice about carbon and why it's the backbone of living things, is because I can attach oxygen on there, phosphorus. Carbon can attach to another carbon, sulfur, nitrogen. Any of those can attach to carbon and share electrons with it. Okay, now look at this. Let's go back to first chapter, right? Here's carbon, oxygen, phosphorus, sulfur, nitrogen. You guys remember this from 2.1. We talked about 99% of the human body is made up of what? How many elements? 6, right? Guess what? 6. There they are. And that's why. So, 99% of just us is these elements because of carbon. And carbon's going to be in the center of all those structures. Okay. I'll show you a picture of that in a little bit. So when we say carbon is the backbone of life's molecules, it really is. I don't care. It could be a fish, it could be a rhinoceros, it could be an oak tree. It doesn't matter. Carbon is going to be in the center of all those things. Okay. Now, here's why. Since it has those 4 valence electrons, the key word up here is strong. They'll share strong covalent bonds. And kind of redundant statement. There's those elements again. But when you share electrons, remember covalent shares, right? So when we share those electrons, that makes a pretty tough bond to break. So obviously, if I want my kidneys, my liver, my heart, I want organs in my body to hold together really strongly through my whole lifetime, right? well, then carbon's going to be in the center of that, which makes sense because it allows us to have stability and have our organs last and have durability and that type of thing. Okay. So when you look at carbon, as you can see here, you literally can form millions, let me say that again, millions of large complex structures. So that's why we look like we do. It's how we function like we do. The whole living world of biology, carbon is going to be in the middle. And carbon bonds can be single, double, or triple. And you can see it here. Look at carbon's right in the middle of all these naturally occurring compounds in our environment. Okay, so that's why it's so important. We still call it organic chemistry today. It probably should be called carbon chemistry, probably would be a better name. But organic chemistry is going to deal with any element or compounds, I should say, that have the element carbon in there somewhere. And that's what we're going to talk about. So what we're going to talk about tomorrow is macromolecules. And we're going to make a foldable, and I'll give you instructions on how to do that. So you'll need to get a glue stick and some scissors. Hopefully you have some of them laying around the house, because that's what we're actually going to do in class today, is we're going to start making those. I will send you a video on how to make those. It's pretty simple, and you actually can use it on your test. Okay, so we're going to start talking about macromolecules and how carbon works in those molecules starting tomorrow. So short notes today. Just want to kind of introduce this next chapter, and we'll pick up from there tomorrow. Okay, so please watch these videos, take notes, look at them, and let's do well on those tests in the future. All right, have a good day. We'll see you. Bye.